Today is day 12 of Unit 5. We started today with a warm-up. So take a minute to pause the video, try the warm-up, and then check your answers. And today I'm just gonna, since my voice still isn't great, I'm just gonna put the answers up. I'm not gonna go through all the steps. So you can just check your answers on the warm-up. Number 1, y equals x cubed plus 6x plus 20 will be your final answer after writing out all the factors and multiplying them out. Number 2, again, I'm just going to give you the answers. So x equals plus or minus 4i, and x equals 3 and negative 1. Again, those are just the solutions after you run through synthetic division twice with the negative 4i and the conjugate positive 4i. Then you'll get a quadratic, which is factorable, and you'll get x equals 3 and x equals negative 1. And number 3, again, I'm just going to give you the quotient, the answer here to the division problem. It is 2x squared plus x plus 4. So that is your answer to number 3. See me if you have questions on any of those. We're going to move right along to the lesson. Here's the topics for you to study for tomorrow's quiz. So let me know if you have questions on any of those. And then we just went right into the lesson. Today's lesson will not be on tomorrow's quiz. So we're solving. So I want to get this set equal to 0. So I'm going to subtract x squared and 8. So I'm going to go ahead and rewrite that in the descending order by the exponents while I'm subtracting. So then I see 4 terms in cubic, which I know I'm going to factor by grouping. GCF x squared times x minus 1. Copy the x minus 1 and then plus 8. And that equals 0. So I can see the GCF is x minus 1. And then x squared plus 8 is what we're left with after we factor out that x minus 1. That product equals 0. So I can see that x equals 1. And then setting x squared plus 8 equal to 0. I can solve that using square roots technique. So x squared equals negative 8. Square root of each side. Absolute value of x equals 2i root 2. So then x is equal to positive or negative 2i root 2. 3 solutions, it's degree 3. I know I have them all. Next, copy this one into your notes. So I know, again, once again, I know I need to get this set equal to 0. So I'm going to subtract 17x squared. And it's set equal to 0. I see a trinomial, and it's to the 4th degree. I know that I need 2 binomials factored. So I know I need an x squared and an x squared. And I need a product of 16 and a sum of negative 17. So I know that's negative 16 and negative 1. Which then I see that factors further. And all that equals 0, so I'm getting plus or minus 4 and plus or minus 1. 4 solutions, degree 4, I have them all. Now keep in mind, back here at x squared minus 16 equals 0, I could, if I wanted to, add 16 and take the square root of each side, and I still would get plus or minus 4. Same thing with x squared minus 1. I could have, instead of factoring, used square roots technique there. Still would have gotten plus or minus 1. Next, x cubed equals 27. Copy that into your notes. Now, hopefully, as you're looking at this, you're not thinking to just take the cubed root of each side and end up with x equals 3. If you were thinking that, then you hopefully would catch yourself and realize that's only going to give you one answer, and this is a cubic. It should have 3 answers. So I know that I'm missing 2 answers if I use that approach. So instead of taking the cubed root of each side, let's subtract 27. Now it's set equal to 0. We see difference of cubes, so we're going to factor into a binomial and a trinomial. X minus 3, x squared plus 3x plus 9. And then I'll solve, getting x equals 3, which is the one answer we knew a minute ago, but we'll also now be able to get the other two answers by solving this quadratic equation, which is set equal to 0. So we can either complete the square or use the quadratic formula here. I'm going to use the quadratic formula. So simplifying that, negative 3 plus or minus the square root of 9 minus 36 all over 2. That simplifies to negative 3 plus or minus the square root of negative 27 all over 2. And that simplifies to negative 3 plus or minus 3i root 3 all over 2. So I have two complex solutions and the one real solution. Now I have all three of the solutions. So earlier in the year, we looked at solving equations that had roots. So this should be a review. I'm solving when I have a square root equals negative 3. So the first thing that I'll do is to undo a square root, I'm going to square. And when I square that, I'm getting 2x minus 4 on the left, and negative 3 squared is 9. So I can solve that easily. The problem, though, is when we have equations of this type that have roots, specifically if the roots are even, we have to check for what are called extraneous solutions. So what I have to do to check that is I have to substitute the answer back into the original equation for x to make sure that it actually is a solution. So when I take 2 times 13 halves, I'm getting 13 minus 4, the square root of that, and that's 9, and the square root of 9 is, not 3. So 3 is not equal to negative 3. That should be a negative 3 there. So 3 is not equal to negative 3, which means this is actually an extraneous solution. It's not actually a solution. So I'm going to cross it off. And because I only had one solution in the first place and it turns out it's extraneous, then I write no solution. Okay. Next, so same idea. I have an even root. I'm going to square root. I'm going to undo that by squaring. So I get x plus 7 on the left, squaring x plus 1 properly. Make sure you properly square x plus 1. You should get x squared plus 2x plus 1. And now I'm going to get everything over to one side. So x squared, I'm subtracting x from 2x, so that's x. Subtracting 7 from 1, so that's negative 6, equals 0. And then solving this quadratic equation. Well, we have a factorable quadratic. So it looks like minus 2 and plus 3. So x equals positive 2 and negative 3. So now I'm going to check those solutions. I have to check them each separately. So let's check x equals 2 first by substituting into the original. And the square root of 9 should equal 3, and 3 does equal 3. So that one works. Now I'm going to check x equals negative 3. So the square root of negative 3 plus 7 should equal negative 3 plus 1. So the square root of 4 should equal negative 2. The square root of 4 is 2. 2 does not equal negative 2. Therefore, I have to cross off x equals negative 3. It is an extraneous solution, which means that only x equals 2 is a solution. Now, because I thought x equals negative 3 was a solution, but it's not, but I do still have x equals 2 as a solution, I'm not going to write no solution. No solution means there's none. I do have a solution. It's x equals 2. Now, had I done both checks and they both ended up not working, then I would cross both off and write no solution. Last, so same idea, we have x to the 1/2. We're going to rewrite that as the square root of x. Remember, we did that earlier in the year. Square root of x is the same thing as x to the 1/2. I'm going to subtract 3 from both sides, so that gives me 12. So I know to undo a square root, I'm going to square. So I'm getting x equals 144. Well, I want to check that because, again, this is an even root. So we're going to check by putting 144 back in. So 144 to the 1/2 plus 3 should equal 15. Well, that's the square root of 144 plus 3 should be 15, and 12 plus 3 is 15. So it works, which means I circle it, and that is my answer. Now, you only have to do the check if the problem had an even root. So x to the 1/2, x to the 1/4, 1/6, even roots. If they're odd roots, x to the 1/3 or the cubed root of x, x to the 1/5 or the fifth root of x, you do not have to do a check. Those extraneous solutions will only happen if it's an even root that you're trying to solve. Your assignment for tonight, in addition to getting yourself ready for tomorrow's quiz, is page 23 and worksheet number 9.